All right, well, let's get started. This question comes from the 2016 AEB International Exam. It's question number 2, which means that it's calculator active. So grab your calculator. You're going to need this. Okay, particle Q moves along the x-axis so that its velocity at any time t is given by v sub q of t is equal to 1 minus 3 cosine t squared over 5. And its acceleration at any time t is given by aq of t equals 6t over 5 sine of t squared over 5. Okay? The particle is at position x equals 2 at time t equals 0. Okay, more important information. In the interval 0 less than t less than 5, when is the velocity of the particle increasing? Well, what does that mean? If the velocity of particle Q is increasing, well, we know that acceleration is the derivative of the velocity. So if the velocity is increasing, that means that the acceleration is going to be positive. How am I going to figure out where the acceleration is positive? Well, we're going to use the graphing calculator. We're going to graph the acceleration function. We're going to make sure to graph this only on the time interval 0 to 5, and we're going to figure out where the acceleration is above the x-axis. So let's switch to the graphing calculator. And we are going to go into graph mode, and we're going to graph our acceleration function. Now, the acceleration function is given to us in terms of t, but our calculator won't do that. So we're going to do 6x divided by 5 times the sine parentheses x squared divided by 5. Before I do anything else, let's make sure I change the window so that I only see the domain that the acceleration is defined on, which is from 0 to 5. And now we're going to look to see where is the velocity increasing, which is where's the acceleration positive. And I can see that we start off here above the x-axis, and we have a root over here. So I'm going to go to Menu, Analyze Graph, 0, a little bit to the left, a little bit to the right, and I get 3.963. That looks pretty good to me. Because the question isn't asking me to do anything else, I'm not going to bother storing. Let's just go back over to the calculator and write our answer in the correct way. We said velocity is increasing. That means the acceleration is positive. And so that's going to be the interval 0 less than t less than 3.963. Now you might be wondering, wait, why aren't we including 0? Why aren't we including the 3.963? Well, for different reasons. In the original problem, they asked me for the open interval 0 to 5, so I'm not supposed to include 0 in that. And at 3.963, we have a root, which means the acceleration isn't greater than 0, it's equal to 0 there. So the College Board awarded 2 points here, 1 point for the interval and 1 point for the reason. This up here is the reason, connecting the fact that the velocity is increasing with the acceleration being positive. So part A is 2 points, and I would expect that most calculus students are going to do pretty well and earn both points here. Let's look at part B. In part B, we're asked to find the position of particle Q at time t equals 3. Well, how are we going to find position? There's a couple of ways that we can go about doing this. I'm going to write x sub q to represent the position of particle Q. The position of particle Q at time 3. Well, how do I get that? They told me the position of the particle at time 0, so I know the position of particle Q at time 0. And if I want to know the position at time 3, what I need to do is add on the change in position, which is displacement. And how do we find that? That's done by integrating the velocity function from the initial point to the point I'm interested in. Let's clean this up a little bit. The position of particle q at time 0 is 2, and I'm going to add on to that the integral from 0 to 3 of my velocity, 1 minus 3 cosine of t squared over 5 dt. Now, before you get too far ahead of yourself here, you might start thinking, oh, well, I know how to integrate this part, and the integral of negative cosine is going to be negative sine. This is calculator active. I don't want to waste time trying to integrate this, because quite honestly, AB students are not going to be able to integrate this correctly because of the t squared. All we're going to do is we're going to go type this in the calculator. So let's switch back to the calculator. And I'm going to go on over now to the calculate screen. 2 plus menu, calculus, numerical integral from 0 to 3. And now type in your velocity function. 1 minus 3 times cosine of x squared divided by 5, and integrate with respect to x. And according to my calculations, negative 1.490. So that's it. That's your final answer. In terms of points, the College Board awarded 1 point for the integral that gets you the displacement. They awarded a 2nd point for use of the initial condition. So right here at this first step, you've already locked in 2 points. And then the last point, of course, comes from coming up with the right numerical value. That is a 3-point question. And still, I would say, pretty kind. These are the kinds of questions I would expect Calculus AB students are fairly comfortable with. If you're not comfortable with this, maybe spend some time, find some other questions, see what you can do. All right, let's see what's going on in Part C. In Part C, we're told about a second particle. Now, this is becoming a much more common occurrence with the College Board. Particle motion gets a little more complicated because now we're going to talk about a second particle. Let's see what's going on. A second particle, r, moves along the x-axis so that its position at any time t is given by a differentiable function x sub r of t, where x sub r of 1 is 4 and x sub r of 3 is 8. Explain why there must be a time for 1 less than t less than 3 at which the velocity of particle r is equal to 2. Well, let's think about this for a second. We know that the position function is differentiable, which implies that this function is continuous and that the derivative exists. Okay, well that's good. It's the fact that they're then asking about proving that the velocity of particle r is equal to 2 somewhere. Putting all of this together makes me think about the mean value theorem. The mean value theorem, or the MVT, says that if you have a function that is continuous on the closed interval AB and differentiable on the open interval AB, if you calculate the slope of the secant line, f of b minus f of a over b minus a, that there has to be a place where the derivative has that value of the secant line. And the key is that this value of c is in between your endpoints. This part here is slope of secant. This here is slope of tangent. Right, that was just a quick reminder of the MVT. Well, what do we know? We have a function x sub r of t which is differentiable, okay, which means derivative exists and we have continuity. If we look at the position function at time 3 minus the value of the position function at time 1 divided by 3 minus 1, we're going to get 8 minus 4 over 3 minus 1, that's 4 over 2, which is 2. According to the mean value theorem, therefore, by the MVT, x sub r prime of t, which we know is the velocity, has to be equal to 2 at least once on this open interval 1 less than t less than 3. And that's what we were after. In terms of the points, looking at the way they awarded points, finding this slope of the secant line got you 1 point, and then your conclusion gets you a second point. Now, it's important, you have to make sure that you've indicated that the function you're talking about, x sub r of t, satisfies the conditions, which is continuous and differentiable. Mentioning the MVT itself is not that important, but you better make sure that you're making this connection that the derivative of position is indeed the velocity. And so this is a 2-point question. All right, one more part. Okay. In part D, we're told at time t equals 3, the velocity of particle r described in part C is -2. Okay. Are particles q and r moving toward each other or away from each other at time t equals 3? Well, let's see what's going on here. At time t equals 3, the velocity of particle r is -2. So the velocity of particle r at time 3 is -2. And they told us earlier that the position of particle r at time 3 is, what was that? That's going to be 8. So my picture right now is if this is my x-axis, at time t equals 3, I'm over here at 8. Let's get a little reference point here. Here's 0. Here's t equals 8. And at time 3, the velocity of particle r is negative, meaning that I'm going to be moving to the left. Well, that's information about particle r. What do we know about particle q? Particle q, we haven't looked at particle q in a while. Well, let's see. What do we know about particle q? We figured out earlier that at time 3, particle q is located at -1.490. So that's over here, -1.490. I'm not ready to answer this question though, because if the particle is moving to the right, then you'd say the particles are moving towards one another. If the particle is moving to the left, then you could say the particles are, I guess they're moving away from one another. But the only way you're going to be able to figure that out is to figure out what is the velocity of particle q at time 3. Now I'm going to have to go back in my notes here, but we were told that the velocity function for q was equal to 1 minus 3 cosine t squared over 5. So in this case, 1 minus 3 cosine of 9 over 5. Take a moment and calculate that on your calculator. What you're going to get is that this has a velocity of 1.681, meaning a positive velocity, meaning that your particle is moving to the right. So what do we know? We know now that at time t equals 3, the particles are moving toward each other. Okay, part D is definitely trickier. If you don't get yourself situated with a nice diagram, you may not get through this. So the College Board awarded 1 point for the answer. Now, if you just randomly said at time t equals 3, the particles are moving toward each other, but there's no supporting work, I'm confident the College Board is not going to award you any points. But if you've got your supporting work, you get a point. And if your conclusion is correct based on the supporting work, you're going to get the other point. This is a grand total of 2 points. If I was a calculus student getting ready for the AP exam, I would make sure to look over this question again, because this is definitely the direction the College Board has been moving the last couple of years. This whole idea of two particles, maybe sometimes they're both moving on the x-axis. I've seen one where one particle moves on the x-axis, the other one moves up and down on the y-axis. All sorts of crazy things going on there. Good luck.